Thank you all for responding to Prachi's request for loud applause. I feel energized, right? Thanks to that. So let me tell you before I start, it's always special to come to India and give a talk and talk about stuff that's near and dear to my heart, speech and language, conversational AI, etc. Thank you all for showing up in such large numbers for this event. As you know, this is the first Alexia voice conference, voice summit, VoxCon. So it's super energizing for the whole team to see this response. Huge amount of effort, as you can imagine, went into planning this event. So with that, let me start. Prachi already introduced me. I'm Prem. I'm going to talk about a little bit about the overall Alexia story, and then the challenges that we sort of overcame for India. India is sort of an interesting experience linguistically, always. And then we'll talk about a few other things. Okay. So first, a lot of our technology dreams come from science fiction, are often rooted in science fiction. It's sort of interesting how science fiction has anticipated a lot of things that come by 20 or 30 years after people first imagine it. And one of the first things is the Star Trek computer, right? All of us, at least when I was growing up, I was in my teens in the early 80s, the Star Trek reruns, the black and white reruns were running on Doordarshan, and every week we'd be looking for the next episode. And then when people talked, say, computer, tell me this answer, it felt magical, right? And it's a tremendous delight to be able to deliver that magic into the same homes where I once saw it on a black and white television, right? So the power of conversational AI is really that, so AI has been around for a while, machine learning has been around for a while, and there's been a progression, right? It started off with character mode interfaces, accelerating a little bit. The web came to the desktop. So now, instead of your computer being sort of a smart device on its own, it became a window to the rest of the world. The thing after that was the mobile devices, which really meant you could carry that window to the world with you. But then after that comes this ambient computing revolution, where the computing is no longer resident in something that you're carrying around you, but you're talking to your environment, and your environment speaks back to you, talks back to you. That is a freeing revolution, because you're doing things the way you always did, except now the environment seems to respond more intelligently to you, right? So at Amazon, once we sort of created this new niche of conversational AI, ambient computing, we then made sure that there was a device for every occasion, there was a device for every room, for every kind of use that you could imagine, right? So what did it take to put sort of this experience together and to deliver it in the form of that compact device that sits on a dining table or on a dresser table, right? So there are sort of 5 major components that we'll talk about today. So you see that on screen. There's the wake word detection. This happens on device for most of you. So Alexa first makes sure that you're talking to her before she starts responding to you, right? The rest of the processing happens on the cloud. Sorry? I can't hear you. Anyway, so the rest of the processing happens on the cloud. So first there is speech recognition. Then there is interpreting the output of that speech recognition, understanding what the query actually meant, and then translating it into action by looking up maybe your knowledge bases, your knowledge graphs, et cetera, right? And then as we're moving away from single-turn interactions to multi-turn interactions, there is the need to manage the dialogue flow. And we'll talk about it when we talk about how we carry over context across different turns of a dialogue. So the common theme, so we saw like a few different components in those boxes, but there is a common theme that binds these components together, and that's data-driven machine learning. So just to set sort of the context, what do we mean when we say data-driven machine learning? So really there are 3 major steps or components or process steps for this. First is that there's a probabilistic modeling, which is robust to noise. So the important thing is, in the real world, there is no perfect data. There's always noise in the data. So your modeling techniques have to be able to manage this variability to some extent. And when you come to a place like India, that variability manifests itself in the extreme. The second is that you want, because all of these algorithms learn from data, you have to feed them a lot of data. Data can become expensive, so you need to come up with inexpensive methods of creating data, creating ground truth. And the last part, of course, is that these techniques, you don't want them to be point solutions. You want them to be portable to new domains, to new languages, etc. This is why today we are able to move Alexa along to a lot of different languages, to new locales, to new geographies. So a graphical view of what I just talked about. We'll build this up from the bottom. So first there is this thing called the trainer. It's surprising. At its top level, at the conceptual level, machine learning is really this simple, or at least supervised machine learning, which is 95% of machine learning even today, right? Which is you have what we call a trainer or a modeling engine, whatever you want to call it. It takes in two things. It takes in the input training data, which is really the raw signal, along with answers that some expert human has provided it. And from that, it learns the parameters of something that we call the model, right? The model abstracts everything that the system knows to learn from the data, represents it numerically, and that's the output of the training. At that point, you're done with the training, right? Now you move to inference. This is what happens at runtime. The inference engine is what's running at runtime. At the time of inference, the inference engine is sort of similar to the trainer in that it gets the raw input signal. But it doesn't get the answer, of course, because that's what it's generating. Instead, as input, it gets this model. And you can think of this model as encapsulating all the knowledge that was taken from the training data. And that's what's allowing it to generate the answer that a human expert might have generated. Now, using all of these things, the techniques that are retargetable to languages, that can be scaled up for new domains, etc. Alexa is now available in more than 80 countries, and it's available in 15 language variants, including, of course, as you all know by now, in Hindi, which is sort of the big news of this week. But this journey, even though Amazon initiated this journey, even though we launched this journey has only been successful because of tens of thousands of developers across the world who have sort of accelerated our momentum along the way. And so part of the reason why we are having events like these is to see how we can catalyze that momentum even more. So now you have a skill for every desire, for every need. In India, of course, there's 90,000 skills worldwide, and there's 30,000 skills available in the India App Store, right? Including All India Radio. I think there was one for Man Ki Baat, which I don't see here, but there's a skill, any kind of skill that you want, it's there, right? So thanks to you all. We have a skill for every moment in your life. If you think of your daily life as it progresses, you want weather reports at some point, they get stressful, you want to meditate. Now you're feeling very calm, so you want some news to spice it up. It's evening, your kids are home, they want to do homework. And in fact, my youngest daughter, Alexa, has become part of her homework routine. I don't know how many of you know, you can ask Alexa math questions. What's 55 times 785? I don't know how many of you can answer it right off the bat. Alexa can, right? And so, or if she's writing an essay, and she has to write about the 35th US president, now it's become a conversation where she's talking with Alexa, learning more about the president, learning about the different things that the person may have done, and then completing her essay. This actually does free up time for parents. It's surprising, because now they're talking to the device, and it's engaging in a way because it's interactive. And then, of course, it's India. Food is important, cooking is important, and so, you want to access any kind of recipe, you want to make sure you're following the recipe right, you want to set up timers for yourself, you can do all of that, right? But central to this theme also of the developers developing skills has been this underlying effort at what we call democratizing AI. And democratizing AI has two aspects to it. One is anybody should be able to develop. So a lot of people, creativity is spread out across the world. A lot of people have ideas about the experiences that they want to deliver, right? You should be, democratizing AI is about making sure the people who have the ideas, the creativity to deliver the experiences they want to deliver, should be able to focus on those experiences and not have to worry about developing these fundamental components that enable the delivery of those experiences. So that's one aspect of democratizing AI. A second aspect of democratizing AI that's important to us is that the benefits of AI, the services that can be delivered through AI, the rich experiences that can be delivered through AI should be available across the world. This is what's driving our expansion across the world, driving our adoption of new languages, et cetera. So those are the two different prongs of, we see ourselves as simply the vehicle through which experiences are delivered and consumed. We're not necessarily the sole developers of these experiences, okay? And so there are more than, with all of those, actually, let me just go back to the thing. There are two, I just mentioned there are two things that are important, but we deliver this democratization through two different ways. One is through the Alexa Skills Kit, and the other is through the Alexa Voice Services, which many different device manufacturers, et cetera, can use to integrate Alexa into their devices. As a result of all of this, you now have 60,000 smart home devices that are Alexa enabled. 7,000 brands can exert their presence through the Alexa vehicle. Our promise always, as people are interacting with Alexa, our promise is that Alexa becomes continuously smarter, right? And delivering on this promise of a continuously smarter Alexa, an Alexa that's always learning, are 5 what we think of as threads or pillars for machine learning or AI, right? And the 5, I'll just show you here. Context awareness. Humans use context much more than we think we do. A lot of stuff that we interpret, if you took the context away and just looked at the sentence, is very ambiguous. We naturally incorporate context. And so in order to enable the device to incorporate context, it takes some real thinking, right? Naturalness, the more natural something, in fact, I'm sure a lot of you, especially in India, this phenomenon is very common because there's so much variability in speech. There's a phenomenon called entrainment. When you're talking with someone and you notice that they're talking in a very different kind of pronunciation or different kind of accent, you will naturally start adapting your pronunciation to the way they're talking, right? That's called entrainment. And the reason humans do it is because the more somebody sounds like us, the more satisfying we find that interaction to be. So naturalness turns out to be very important for engaging, right? Another part is self-learning, right? We can teach Alexa all we want, just like we teach our kids a lot before we send them out into the real world. But the way they succeed and they flourish and they blossom is by learning on their own, by taking feedback and going incrementally beyond what was taught to them. That's an important attribute for a conversation or any world-class AI in any domain to have. And then there are 2 things which are a collective enterprise, right? We all like talking to knowledgeable people, people who know a lot, because we can learn a lot from them. So we want Alexa to be very knowledgeable. We alone cannot make Alexa knowledgeable. That's a community effort. In particular, this community of developers, especially for a country as diverse and varied as India, it's important for it to be a team effort with the community of developers. And the last is competency, making Alexa more competent. Skills are a way of expressing competency. And so creating more skills, creating more capabilities is, again, a joint effort. And we're counting on everybody in this room to make Alexa more knowledgeable and competent for India. Okay. So now context aware. I'll accelerate through. Now I've given you this sort of overarching context. I'm sure you all will be able to interpret the next few slides fast. So we'll go through them a little quickly. So context aware. I'll give you 3 examples of context awareness. So one is discourse memory, where a discourse is just an interaction that you're having, that you're talking to somebody. It's a discourse. So you ask Alexa, what's the weather like in Delhi, right? And Alexa says, that's what it is. And then you say, what about tomorrow? It's not immediately apparent to us as humans when you're doing this that there is some context here. But if I was to just ask you the question, what about tomorrow what, right? There's not even an it. What's the weather like there tomorrow? So it's not even an explicit substitution. It's pretty latent. You have to carry over this context. So this requires some work. And so we had to create some new science in order to deliver that capability. And for those of you who are interested in deep learning, the details are on screen. the first one that you see there, the name entity recognition intent classification, that's just what you do when you're interpreting the utterance that you have. But when you want to maintain memory across the history of the discourse, then you have to create this conversational level interpretation module, which says, I have a notion of what's a conversation, of what's a discourse, and I'm going to hold context constant throughout the discourse so that when somebody says, what about tomorrow? Because just as easily as what about tomorrow, that utterance could have been, what about Bangalore? And now, the thing that you're carrying over is the tomorrow and not the location, right? Next one is whisper. This is a different kind of context. I was just talking about entrainment. You can try this experiment as many times as you want. You whisper to somebody, they'll whisper back to you. That's just the nature of things, right? So we want to make interactions with Alexa more natural. You whisper to Alexa, we want Alexa to whisper back to you. So what happens there is, anyway, this is the technology behind it. When the customer's utterance comes in, by the way, whisper is deceptively hard. It's not just that you're listening to speech at a lower volume. The way in which you talk changes. The way the words are pronounced changes. The ability to distinguish between the atomic sounds that constitute words changes. And then if you have the fan running, whisper is less audible. You know, there are things about vocalization that carry through distance that don't carry with a whisper, right? So this was a hard science problem to solve. We'll give you an example so you can see how this experience sounds like.
Rough day. What's for dinner? Shh. Alexa, open Domino's.
Hi, welcome to Domino's. Would you like to place an order or track an order?
You know, the interesting thing about that joke, humor is not just culturally contextual. I think it's also age contextual. Yesterday we had a slightly older audience. There wasn't as much laughter with this video. Today I noticed that, you know, the crowd is younger and you're enjoying this joke more. So there must be something that's more relatable to a younger audience here, right? So, you know, I feel quite young too. One of the joys of being in academia, you feel young, right? So acoustic events. So another way of context is interpreting the sounds that come. So far, all the sounds to us have been words, you know, language, they carry content. But sometimes meaning or semantics comes through even when there's no content. One example I'll give you is what you all did when I came up, you were clapping. That's a way of cheering, encouraging someone, energizing them, etc. So there's meaning to it. There's intent behind sounds. So similarly, when you have you know, somebody kick, you know, Indianizing the slide, I would have put a red cricket ball, right, in there, and that would be coming through the window, and the window would be breaking, and then you would see a bunch of kids running away and trying to toss the bat in somebody else's hand, right? But when that window breaks, right, that sound is the sound of window breaking, and the possible meaning there is somebody is gaining unauthorized access to your house, and you want to be alerted when that happens, right? And so Alexa now in the US, it actually sends you an alert, a message to your app saying, I heard some activity in your house that sounds like somebody might be trying to break in. And then if you have a smart home with smart cameras, et cetera, you can actually check it. And there's actually already reported evidence where this has helped improve the security of houses, where people have been able to get criminals caught, right? So again, sorry, somebody's trying to take a photo. I'll put it up there for you, right? Okay. So this is sort of, you know, think about it as multitask modeling. So for those of you interested in deep learning a bit, you know, with LSTMs or with all of these neural networks, you can train them to do one task at a time, right, which is speech recognition. You can also train them to do multiple tasks at a time on the same input signal, right? So recognize the speech and recognize the speaker. That's called multitask learning. And when you're doing multitask learning, you get certain efficiencies of data, et cetera, and even performance. And here we use multitask learning to say, same signal comes in, but you're going to produce different things out. Is it a smoke alarm? Is it a glass breaking, et cetera? Right? Natural, we talked about how important it is to make Alexa natural. So I'll give you I'll start with an example of how we make Alexa natural on the output, right? which is how does Alexa sound more natural to you? There's going to be two examples we play. This is neural TTS. Just for those of you who care about such trivia, Hindi is the first locale that we're actually launching directly with neural TTS. All the other locales were launched first with concatenative TTS, and then neural TTS was added. So so we had to create this concatenative TTS so you can hear what it sounds like. When you're listening to the next two examples, they sort of run through quickly, so I just want to give you a pointer. Listen to the way Sachin and Ramesh, and for those of you cricket buffs, you know how the trigram ends. It ends with Tendulkar, but listen to Sachin and Ramesh, the first two words, and then at some point she'll also say Gine Chune, and then you hear the inflection in the Gine, and you'll see the difference between the naturalness of the I think the examples are missing, so we will need to find them. That slide should have had maybe a couple of examples, but we'll flick through, maybe they're later in the slide. So this is just for the technology buffs among you. We used concatenative TTS was the traditional technology. Neural TTS is the new one, which makes it much more natural. And it's because of the way there are differences in the way these things are creating the speech too. In the one case, it's trying to splice together appropriate speech segments together that are taken automatically from a person who's giving you their voice. In the other case, you're directly taking an input sequence of words and trying to generate the output speech. Right? We'll move on to the next way of natural, which is on the input side, which is multiple step request in one shot. So oftentimes we want to say, Alexa, add chocolate to my shopping list, add haldi to my haldi add kar do, whatever, right? Going one at a time is painful, especially if you're creating a shopping list or you have a yadi, you already have like 10 items in your mind. So with multi-step request, one thing you can do is you can just give it a list of things to add, and it will add them all at one shot. Right? This is called multi-valued slots. This is a capability that can be exploited. Second one is multiple intents, where you're actually trying to accomplish multiple tasks. In the one case, you're trying to accomplish one task, which is adding stuff to your shopping list. You just want to add multiple things to your list. Another thing is multiple intents, where you want to say, Alexa, play Sunflower, which might be a song or a video, and turn off the stage lights. Right? This is not yet launched here, but this will come. So multiple intents in one shot is where you can actually ask it to do. Play jazz music and dim the lights, right? Things like that. Natural skill interaction now, of course. So we talked about naturalness on the output, naturalness on the input side. Naturalness on the skill interaction side is if we ask Alexa to, you might ask Ola to book a cab. So in this case, you have to know, you have one skill, you have 5 skills, you have 20 skills. This is doable. But once you have many more skills than that, it becomes a discoverability challenge. Really, from a customer perspective, we want to minimize the friction to the customer as much as we can. So really, the customer, all they care about is we want a cab. You might have set your preferences somewhere that give us an indication. Is Uber your preferences, Lyft your preferences, Ola your preference? And then we use that as context. So we take in the input that comes in, we shortlist the intents that make sense, and then we take the context, user preferences, what are the last few things you ordered, etc. Use that to re-rank the output for your request, and then deliver to you the experience that you want. Right? Then I'll talk about self-learning. Important, I'll motivate it with an example, the one that you see on screen. Right? Kids adults call it the alphabet song. Kids typically call it the ABC song, especially if they're 3 years old or something. The ABC song, that's sort of the natural way in which they say it. But the first time you go and say, play the ABC song, Alexa may not know what the ABC song is because whoever developed that solution knew it as the alphabet song. Maybe the catalog had it as the alphabet song. That's the way it was ingested. But let's say my daughter asks it to play the ABC song. And then I go in and it doesn't work. And then I say, Alexa, play the alphabet song. And it plays the alphabet song. And let's say further now that I actually listen to the end of the song. There's a pretty strong signal there that that's the song we wanted. Right? Because the first time we interrupted the song, we reissued the request. Now, if this happens more than once and you're aggregating information across multiple users, you now have a pretty strong learning signal through user feedback, behavioral feedback, saying ABC song and the alphabet song are probably the same. you can learn that equivalence automatically. Right now, this is operating automatically in the US. It's learning on the fly, and the amount of traffic that's going through this automatic correction is huge. In fact, we've generalized it to just rewrite queries that fail, right? So let me give you an example. So you ask for something like you want to know who's the prime minister of a country, and you ask for it in a certain wording, and you insert a couple of words that make Alexa not interpret it properly. You can actually learn how to rephrase it, right? And we'll talk about that later in the slides. So neural semantic, I think, how old is India's prime minister, right? Narendra Modi is 68 years old. In this case, the reason you need this neural semantic parsing, what we call it, is that we're not asking it how old is Narendra Modi, right? There is a level of indirection in this question. Whereas how old is India's prime minister, you have to figure out who is India's prime minister today, right? For that, you need a knowledge graph, a knowledge base that tells you India's prime minister today is Narendra Modi. Then you go rewrite your query and say, how old is Narendra Modi? And then you come back with that answer, right? But there's a different way in which you can use it, right? In that case, there was nothing wrong with the query. It was just a level of indirection, and you needed to look it up. In this case, you ask, is Andaman still a union territory now, right? For some reason, this throws off Alexa. Let's say in natural language processing, it's statistical, it's learned, it will make mistakes, however good it is, right? It doesn't work. We can trigger a paraphraser that says, what's an equivalent way of saying the same thing? And it automatically comes back and says, is Andaman a union territory? All it did was drop the now. The system automatically can paraphrase things, rewrite things. This one comes back with an answer, right? And we deliver that answer to. So this is a generalization of that whole feedback-based learning, that we can actually go and use it to do paraphrasing, right? Competency, this is where we need help from this community to make Alexa more competent, and then, of course, also the more knowledgeable piece. So competency, one way of looking at competency, when we talk about competency, even in a human context, we talk about how many different things can this person do, and how many different things can this person do well, right? So those are the two questions that we answer with this graph. One is, how many different things can this person do? Turns out, in the course of the last 5 years, thanks to all the developers who have participated in developing Alexa up, she can do 90,000 different things, or 90,000 different skills. But the truly impressive piece here is you can start doing more and more things, and typically when you start doing more and more things, you start doing them worse and worse. The important thing here is that as the number of skills has gone up astronomically, the error rate has also dropped. We've upped the error rate just in the last 20 months or so by more than 25%, right? That's a huge improvement, especially when you look at the fact that Alexa is now doing a much more complex set of tasks, and she's doing each one of them better, right? That's something that we're super excited about. How did we achieve this? Of course, today the answer to how did you improve anything in AI is often starts with deep learning. But there are I'll give you a couple of examples of how we have used deep learning, specifically transfer learning and active learning, to help improve Alexa's performance. So transfer learning is when you can transfer knowledge learned performing one task to another task. One example of it could be you have some domains or some skills that are data rich, and you have a lot of data to train the models for that skill or for that domain, and then you have another domain or skill where you don't have as much data, right? It'd be awesome if I can transfer some of the learning from the data-rich skill to the data-poor skill. This is actually deployed behind the skill platform already. It was deployed as of like 6 months ago. Some skills went into production with this. The important thing here is there is no additional work for the skill developer to do. This goes in entirely on the back end. The transfer learning just happens automatically, and when it's deployed to more and more skills, everybody benefits. Second is active learning. Transfer learning is about saying I have a lot of data somewhere, I want to take it on. Active learning tries to answer the question of how can I get the same performance with much less data to start with. And so here we're trying to say, can we actually pick the utterances that we want somebody to mark up for us so that we can learn from them? How do I pick my next training sample? And so we did a fair amount of work. This whole area is called data efficient learning. And in that, for some skills, and some domains, we've actually shown a 40x reduction. So really what that means is if you're using 1,000 utterances before to get a certain level of performance, you do that with 25. Right? And then, of course, we come to the event, which is Alexa of Hindi mein. Right? So Alexa is now in Hindi. Many of you must have followed the launch yesterday. It's in all the newspapers. My friend and talented colleague Rohit announced the launch of Alexa yesterday. High impact event for us, something that we've been working towards for a while. But coming to this high impact launch, again, the last few months have been a fair amount of hectic activity that has not just been at Amazon. So 2 mahine pehle, we launched the developer portal. There was a private beta for some Hindi developers. More than 6,000 developers, they've made like 500 skills se zyada bana chuke hain. I think they're all available on the skills store now. They went live yesterday. And then, of course, more than 30 brands are already in. And actually, at the time of the launch yesterday, Bose was already integrated with Hindi Alexa and was working. So this launch took a lot of coordination with a bunch of people. So solving for Hindi. So Hindi is, so coming to India, the linguistic diversity is huge. Right? It's not just that there's a variety of languages, but the same language is spoken very differently across the country. Pronunciations change, etc. So we had to support colloquial English speech. One of the things happens is we mix words from different vocabularies. The language is Hindi or the language is English. Right? Play swag se swagat. It's an English sentence, but half the content is Hindi. Or play kadala kadala. Right? You say I've launched Alexa in English in India. Everybody expects all of these things to work. Nobody thinks that that's not an English word, right? But it's part of the English experience. So we knew we had to support it. Things like Alexa, Delhi ka Chief Minister kaun hai, right? And then we have to support seamless interactions. A lot of households in India are multilingual. My own household is multilingual. I grew up in Pune. My wife grew up in Tirunelveli, right? Her parents speak Tamil. My parents are comfortable with English and Hindi. Our kids speak English. I speak English, Hindi, Tamil, Marathi sometimes, right? So and you want these different cultural experiences. People are multilingual and households are multilingual. So what are some of the linguistic challenges, just to make them concrete for the audience? So let's look at them in 3 categories. One is spelling variations. We know this is massive in India. Those of you who watch movies know the number of different ways in which pyar is spelled. And for those of you who are interested in certain kinds of movies, pyar ka panchnama, the panchnama is spelled in a different way, right? You see all these variabilities. The pronunciation varies across the country. The same word, government, is pronounced very differently across the country. Dopaher, but within Hindi, different regions will say dopaher, dupaher, etc. All of these variations are very common. And the last thing is language in India is very dynamic. New movie comes out, Piku. You all want to go see Piku. Nobody thinks Piku is a new word. Which vocabulary will have this word Piku, right? And so you just go and say, Alexa, play Piku. And now Alexa has to play Piku. But Piku is not a word. So what do you do? How does speech recognition deal with it? So these are all challenges we have to solve, right? So one, on the input side, I won't go through this thing. Basically, to take all of those catalogs, normalize them, right? Make them some amount of standardization, right? This is the process we have to do. And the variability is in both. You have variable Latin spellings of the same Devanagari word, and you have different Devanagari spellings of the same underlying Hindi word. So we had to standardize on both of those ends to get a consistent representation so we could deliver a consistent experience to the user, right? Second example I'll give of the stuff that we did was on the entity resolution side. Remember I said spelling variability? You do all the standardization you want. There's still going to be residual variability. So you have to handle it through some kind of fuzzy matching, fuzzy search. And thanks to deep learning, these things can be done pretty effectively now. The other part is a word like Piku, right? The only way you're going to be able to handle this ever-expanding words is by using phonetic search. So instead of looking for entire words, you're looking for phonetic sequences and trying to do matching. And turns out this improves coverage significantly for us in places like India and even Japan. For neural TTS, making it sound more natural. Here are the examples.
सचिन रमेश तेंदुलकर क्रिकेट के हिस्ट्री में विश्व के सर्वश्रेष्ठ बैट्समैन में गिने जाते हैं। सचिन रमेश तेंदुलकर क्रिकेट के हिस्ट्री में विश्व के सर्वश्रेष्ठ बैट्समैन में गिने जाते हैं।
Okay. So it's in the acoustics of this room, it's not immediately apparent, but if you listen to Alexa at your home and you ask her to play some of these things, you'll notice inflections in the word like Ramesh versus Ramesh, right? Or Gine, Gine. Those inflections come through much more clearer and sound much more natural with the neural TTS. Next thing, of course, Alexa for multilingual households. So we want Alexa to seamlessly switch languages. So you ask one question in Hindi, you want her to answer in Hindi. This is what we do. Somebody talks to us, they ask a question in Hindi or Tamil, we answer it. Somebody else asks us in English, we answer in English. And we want to provide the same experience. So that experience is coming soon in India, right? This is already being tested extensively. We're doing lots of user testing, etc. This is coming soon. But let me give you...
Alexa, कोई फिल्म डायलॉग सुनाओ।
मुन्ना भाई की ओर से
Alexa,
ये रही एक
give me list of Ayushmann
टेंशन लेने का
Khurrana's
नहीं,
movies.
सिर्फ देने का। I know about 23 Ayushmann Khurrana movies, including अंधाधुन, विकी डोनर, बधाई हो, दम लगा के हाइशा, and 19 more.
Alexa, अंधाधुन फिल्म कब रिलीज हुई थी?
फिल्म अंधाधुन 5 अक्टूबर 2018 को रिलीज हुई थी।
Alexa, play nursery rhymes.
Countdown Kids Nursery Rhymes Amazon exclusive by the Countdown Kids on Amazon Music.
Alexa, दिवाली कब है?
दीपावली 27 अक्टूबर 2019 रविवार को है, जिसमें अभी 1 महीना और 9 दिन हैं।
So this is the experience, when I said coming soon, this is the experience you'll be able to enjoy at home. If you have people who speak all those different languages at home, you'll be able to try it out soon. So what is the change that we had to make to the system? You already saw this system diagram before. So the new addition here is this thing that we call language detection, right? So the rest of Alexa operates the same. You have the wake word operating as before, but now we do language detection. And imagine this, the language detection has been done fast enough so that it doesn't feel like there is an extra component processing that's making you wait. And so there was some real key, not just science problems, but engineering challenges to overcome in making sure this is super fast so you can have this experience and make it feel more natural. In order to handle the multilinguality, of course, and the variability in the dialects, usually you collect data from a number of people, you train your system, embodies that. But when you're faced with the diversity of a place like India, you need to have a massive collection scheme, which is not possible to do in the traditional way. So we had put out this skill called Clio, right? Where people can participate in teaching Alexa. So, you might be an expert in Hindi and says, Alexa, Alexa may ask you, how do you say, what's the time now in Hindi? And then you tell it how you say. Now, the same skill is deployed across India, and a lot of different people participate in this collection. And Hindi crowdsourcing was, in fact, one of the most successful experiences for us. There were, for new languages, we use Clio, but 150 plus different dialects. But just in Hindi, the dialectal variations and the accent variations, they're all mixed up together. So it's hard to quantify the thing for Hindi. Millions of phrases have been collected. Just for Hindi, we were able to collect more than 1 million phrases using crowdsourcing. So we're really very grateful to a very large community that has helped us train Alexa for Hindi. Right? Last thing I'll mention is, for Hindi, the utterance collection was, because of the participation of folks, 8.6 times, being very precise, 8.6 times faster than we've experienced before. Right? So it brings me now to the story. Alexa is learning every day. She's becoming better. And all of that is happening thanks to thousands of developers like you who contribute to Alexa every day, building skills, evangelizing about the voice story, evangelizing about conversational AI, and contributing to the Alexa developer community. So let's take a look at the developer journey in India. And my colleague Dilip will talk much more extensively about the developer journey in India later today. tens of thousands of developers. So India is actually one of the most vibrant, one of the most active developer communities in the world for Alexa. They're not developing skills just for India, you're developing skills worldwide. About 30,000 skills available in the Indian store for India. And thousands of students, so this is unique to India, thousands of students trained by Alexa student influencers. Yesterday we had the Alexa Voice Awards at yesterday's dinner, and one of the students was given the Influencer of the Year award. And so this is sort of an important initiative for us in India. Also, what were the features and programs? How have you all participated? How have we listened to you and come back to you with improvements or with features that you've asked for? So a lot of launches, and I'm just going to go through the ones that happened this year. And after I build up the whole slide, I'll just highlight a couple. One is we heard a lot of questions about how can folks get rewarded for developing skills. So our first attempt at doing that is the Alexa Developer Rewards Program. I'm sure Dilip will talk more about it at some point today. But it's a successful launch. But it's the initial thing that we're doing. It's not the end of the commitment. It's the beginning of the commitment to make sure that developers can benefit from developing for Alexa. The other thing I'll mention is the Hindi Developer Portal, Alexa's first private beta program for India. So back in July, about 2.5 months before this launch, we opened up a private developer portal. A lot of developers were invited. They helped develop this for us. The last, before I move on to the concluding slides, I'll say, give you a little bit of an insight into what the progress in AI looks like. Right? So you can look at AI, and we sort of think about this AI stack view, right? Where you look at the bottom of the stack, that's sensory data. That's just the sensors, right? There's the microphones, the cameras, et cetera, listening to things or seeing things, producing the signals that you want to understand and interpret. The next thing is you have to model those phenomena. So within those signals are words maybe, or objects. So you want to model those phenomena so that you can recognize those phenomena and interpret them and provide them for the decision systems, which are next higher up on the stack, to make decisions with them, right? But beyond, so right now, a lot of AI is in the sensory data to intelligent decisions frame. Where we are pushing Alexa now is towards reasoning. So there are things like Alexa Conversations, et cetera, that are being launched that actually perform inference or reason over complex sequences of things to understand latent goals. So if you ask Alexa, what movies are playing tonight, maybe, and then you ask her for restaurant things, maybe Alexa can understand that you're trying to plan a night out and start helping you and guiding you along that process. So that's sort of the reasoning piece of it. Beyond it is autonomy, where Alexa learns on her own, does new things on her own, et cetera. At the top of the stack is this thing called automated general intelligence, which, it'll be great to even see a glimpse of it by the time my life is done. I don't expect us to get there anytime soon. If we get autonomy, I'll be delighted, right? It's still day one at Amazon, so even though we're moving up the stack, each one of these movements for us is a pleasure, an excitement. We're pushing AI forward. We're pushing AI forward in a way that it's affecting the lives of millions of people worldwide. People are interacting with the advances we make. They're benefiting from those advances we make. And they're also teaching us what are the gaps in the technologies we're putting out so that we can improve it and deliver new capabilities. Now moving on, just to say, you say, we listen, we act. We've created a new Alexa Skill Developer Voice and Vote for Hindi. It's a portal. There will be an announcement here. I'm sure Dilip and his team will put out some news around it, and you'll be able to participate actively. Now that we've launched Hindi, we want to hear back from you all. How can we improve the Hindi experience even more? How can we make it even more magical for the Indian customer? And how can we help you make it even more magical for the Hindi customer? And then I'll end with a video where we'll say, meet the pioneers from India.
We started looking out for games that are popular, things like rock, paper, scissors, something very simple. We've seen all the cartoons that are there.
Rock, paper, scissors.
Rock.
Rock. How did you guess my move? Hope you are not cheating.
The key thing is to have the invocation name that is very simple. So we learned it the hard way where we did the beta, and the first invocation name was Oiku Stories, and our beta users had a tough time kind of invoking the skill. So reset everything to Story Stream. Alexa, open Story Stream.
Ahoy! Welcome back to Story Stream. We have immersive stories in Hindi and English collections. Which collection would you like to explore? Hindi or English?
Hindi.
Ji busy. Hindi it is.
The first thing which I keep in mind is that the attention span of the users is usually very short. So it should not be a boring conversation with Alexa. It should be interesting, it should be entertaining to the user. So I try to keep the entertainment part in the skill.
The first time I came across Alexa there was an open hack where the participants were building the skills, but unfortunately my skill failed in front of everyone. I went back home, completed the skill, and 2 days later it was live on the skill store. It felt quite proud to see my name on Amazon.com.
Hindi definitely provides us a native connect. Speaking in Hindi to a device will just make it very natural.
For example, we developed rock paper scissors, which was a heavy influence from the Western culture, right? Western side. Now, what would our native speakers or Hindi speakers, the majority of India, actually the kids play? And one very good example is Chidiya Ud or Lukha Chupi.
Mendak ud.
Pass.
Shehnai ud.
Ud.
Alexa, open Wild Planet.
Meow. Welcome to Wild Planet.
Kids are like asking more and more animals, right? Actually, we learned a lot of animals. We don't even know how these animals sounds like, but Sridhar and team, they went on and they looked for more and more sounds. Actually, that's actually a little interesting for us. When we see this, kids are interacting like this, right? It's like making us more like feeling proud. Actually,
we are actually doing something good here.
I really enjoy the experience with Alexa.
It definitely is a very good feeling.